Hey there, how's it going everybody? In this video, we're going to be learning about variable scope in Python. Now, understanding how the scope works is one of the more important concepts when working with the language because it's something that we're going to need to understand in just about every program that we write. And understanding this also helps a lot when a variable may not have the value that we expected and we need to debug our code. Now, if you don't know what I mean by variable scope, now this is what determines where our variables can be accessed from within the program and what values those variables hold in different contexts. So let's go ahead and look at some examples to get a better understanding of this. So there's a common abbreviation for understanding the scoping rules within Python, and that abbreviation is LEGB, and this stands for local, enclosing, global, and built-in. Now, the local is which are variables defined within a function. Now, enclosing are variables in the local scope of enclosing functions. And I'm going to go over examples of all these in just a second. And the global are variables defined at the top level of a module or explicitly declared global using the global keyword. And the built-ins are just names that are pre-assigned in Python. Now, the reason that the abbreviation is in this order is because this is the order that determines what a variable is assigned to. So Python first checks the variables in the local scope, then the enclosing scope, then the global, and then lastly the built-ins. Now, we're going to look at all of these in this video, but instead of going in this exact order, let's first start off with the global and local scope because these are probably the most commonly confused. So let's say that I have a Python module here where I simply set a variable x equal to a string global x. And let me go ahead and just make this text a little bit bigger here. Okay. Now, the variable x here is a global variable because it is in the main body of our file. So now let's make a function here, and I'll just call this test. And within test, I'm going to create a variable y, and I'm going to set this equal to the string local y. Now, this y variable here is a local variable, and it's local to this test function. So if I were to print out y and then outside of this function run that function, now you can see at the bottom here that it prints out local y. So Python used that LEGB rule when I printed out that y variable, and it said, okay, so first I'm going to check if I have y in my local scope, which are variables that are defined within the function, and it found that local y variable and printed it out. So now within this test function, I'm going to comment out that print y, and instead I'm going to also print x here. Now I'm printing x from within the test function. So let's try to imagine what's going on here if I do this. So if I go ahead and run this, then you can see that even though we're within our test function, it still printed out that global x. And the reason that it printed out global x is because it said, okay, do I have an x variable in my local scope, which means that it's defined within this test function. So it doesn't. So now that it doesn't find it there, it says, do I have anything in my enclosing scope? And we haven't gone over enclosing scope yet, but we will in just a minute. But I'll just tell you that it doesn't find an x in that enclosing scope either. And then it checks if it has an x in its global scope, and it does. So it prints out the value that it found in that global scope, which was global x. But this doesn't go both ways though. So for example, if I come down here after my test function and I say print y and run this, now you can see that we got an error here and it says that name y is not defined. Now if you're new to Python, then you might think, well, I ran the test function here, which should have set that y variable, and now I'm printing the y variable here, but the y variable doesn't live outside of that test function. When we print this y variable out here, it doesn't find a y variable in its local scope, enclosing scope, global, or built-in. So then it throws that name error. Okay, so now instead of printing this y from outside the test function, now let's print that x variable, and let me save that and run it. So now you can see that it sees that x global variable from within the test function and from without. Okay, so now within the test function here, let's change this y variable here from y to x, and inside here I'm going to say local x, and I'm going to save that. Okay, so now before I run this, it might not be obvious what this will print out. So let's go ahead and run it. So when I run that, you can see that it ran the test function here, came in and printed out this local x, and then this, it comes out and prints this x after the test function, and it prints global x. Now, some people might think that the global x variable would have been overwritten here within the test function, but that's not what happened. So this just creates a local x variable here that lives only within this function, and anything outside of that local scope still sees the global x variable. Okay, but what if we actually wanted to set a new value for that global x variable from within this test function? Now, to do this, we can explicitly tell Python that the x variable we want to work with is the global x variable. And to do this, at the top, we can just say global x. And now it knows that we're working with that global x variable. So now, if I rerun this, then you can see that it ran this test function, came in and said that we're working with this global x variable, set that to local x, printed that out, which was local x, and since we explicitly told Python that we wanted to change that global x variable, when we printed it even outside the function, it still printed out this local x string. Now, having this string set to local x is a little bit misleading now because that's no longer just in the local scope, it's now in the global scope. Now, one thing about this global statement is that we don't even have to have a global x variable defined before we set it here within our function. So if I come up here and I comment out this global x variable and then rerun this code, then you can see when we set this global x within the test function, even though it didn't exist up here, that it was still able to find that variable when we printed it out down here at the bottom. Now, that only works when we're setting that as a global variable. So, for example, if I come in here and comment out that global x, now we're just setting that locally. So now if I run that, then you can see that it printed out that local x from within the test function, but this print statement outside of the test function threw an error because that global variable is no longer set. Now, a lot of the times it can be tempting to learn something new and then overuse it. I wanted to show you the global statement so that you know what it does and how to use it. But honestly, I don't think I've ever had the need to use this myself. And if you find yourself using it often, then you're probably doing something wrong. So using the local scope of a function makes it easier to understand and easier to work with. So you can imagine how difficult it would be to maintain our code if you use these global statements and had to worry about variables in your functions overriding values outside of that function. So with the local scope being self-contained, it allows us to not have to worry about what's going on outside of our function. So I wanted to show you how the global statement works, but be careful not to overuse it. Okay, so now I'm going to go ahead and get rid of this global x statement here. Okay, so now all of us have most likely seen functions that take arguments. So let me add an argument here to this test function, and I'll just call this variable z. Now z is going to be a local variable within this test function also. So it's not going to exist outside of that function either. It's just like when we set our local x variable within this function. The only difference is that as a function parameter, it can now be assigned values that are passed into our function. So for example, when I call my test function down here, now I'm going to pass in local z, this string, and that's going to set that local variable z equal to this local z string. And so now within that function, instead of printing out this x variable, I'm going to print out z, and I'm just going to comment out this outside print statement here. Now, if I run this, then you can see that we passed in that local z string. When we printed z here, it first looked in its local scope, and z is in its local scope, and it found it there, so it printed out that local z string. And just to show you what it does if we try to print that outside of that function here, I'm going to change this with print z, and if I run that, then you can see that we got our name error. Name z is not defined, and that's because that z variable is only local to that test function. So now I'll go ahead and comment out that and rerun it. Okay, so now let's take a look at the built-in scope. Now, this one is pretty easy to understand because it's just names that are pre-assigned in Python. So for example, min is a built-in function in Python that finds the smallest value of an iterable. So for example, I can use min by saying m equals min, and I can pass in an iterable. So in this case, I'll just pass in 5, 1, 4, 2, 3. And now I'm just going to print m below here, and let me comment out where I'm running that test function. Now if I run that, then you can see that it prints out 1 because 1 is the smallest value in that iterable. Now we were able to use min here because it's a built-in function in Python. So if we'd like to view the variables that are within the built-in scope, then we can simply say import built-ins, and then after we import that, then I can just print out dir on that built-ins module. Now dir just gets a list of the attributes of a given object. So if I run that, and then let me drag this up a little bit here, you can see that it returns all of the built-ins here. A lot of these are exceptions and error names. Then if we scroll down here, then you can see some others that we're more used to. So we have like print and min and max and int and list and range and a few others that you're probably familiar with. Now, one thing that you want to be careful with as far as built-ins go is accidentally overriding them. So this isn't something that Python prevents us from doing. Now, there's reasons for this, but basically they're just trusting us with having the power to do that. So for example, if I was to create a min function here, so let me comment out that printed built-ins there. So if I was to create a min function here, and then I'm just going to put in a pass statement there. So now before I run this, I'm just going to comment out where I use that built-in min function here. So now I'm going to run this, and you can see that I don't get any errors. But now if I try to use that built-in min function that worked just a second ago, so I'm going to uncomment out that code and run that, then you can see that it gets an error saying that min takes 0 positional arguments, but 1 was given. Now the reason for that is when we ran this min function here, Python found our min function in the global scope before it fell back to the built-in scope. So you have to be careful with that. So if I change the name of my global min function here to something like my min and rerun that code, then now you can see that it works again because now it doesn't find min in that global scope and instead uses the built-in min function just like we expected. Okay, so now we're going to take a look at the E part of that LEGB rule, and that stands for enclosing. Now before we do that, let me go ahead and clean up some of this other code here. So I'm just going to comment out everything except for that global X and that print X there. Now the reason that we saved the enclosing scope for last is because it's easier to understand once we understand the local and global scope. So the enclosing scope has to do with nested functions. So let's say, for example, that I have a function within a function. So I'm just going to say I'm going to make a function called outer here, and within here I'm going to set an x variable equal to outer x, and now I'm going to have a nested function. So within the outer function I'm going to call this function inner, and within inner I'm going to have another x variable, and I'm going to set this equal to the string inner x, and now I'm going to print out that x variable from within the inner function, and now I'm going to run that inner function, and now I'm going to print out the x variable from within the outer function, and now to run all of this I can run that outer function in the global scope area. So now I'm going to go ahead and run that. Okay, so I know that there's a good bit going on there, so let's go ahead and walk through this. So we have our outer function here that we ran. So we came in here and we set our local x variable. Now this variable is local to our outer function. And now we come in here and run our inner function. And within our inner function, we set this x variable, and this x variable is local to our inner function. And then we print that x variable. Now it uses our rule, LEGB, so it looked if it had any local x variables, and it does. It has this inner x here, and that's why it printed out inner x here, because that is in the local scope. And then we printed out x in our outer function here, and it looked if it had any local x variables, and it does. It has this outer x local variable, and it printed out outer x here. So now let's comment out where we set our x variable within our inner function. So now if I rerun this, then you can see that it printed out outer x both times. And this is what the enclosing scope is. So when we got to the point within our inner function where we printed out this x, it first checked if it had any x variables local to that inner function, and it doesn't because we just commented it out. So then it checks if it has an x variable in the local scope of any enclosing functions. So that's why it's called the enclosing scope. So now we're looking in the local scope of any enclosing functions. So our enclosing function here is the outer function, and we do have an x variable in the local scope of that enclosing function. So that's why it printed out outer x. So you can see that that's kind of similar to our global and local scope example, except now we're inside functions. But the same concept kind of applies. When we set x in our inner function, it doesn't affect the x variable in the outer function. And just like with our global and local scopes, if I come out here and comment out this outer x, and then uncomment out that inner x, and save that and run that, then we get an error because this printed out x within our inner function because it has that local x variable within the inner function. And then when we tried to print it outside of that function, it checked its local scope, but that's commented out, and then its enclosing scope, which it doesn't have any enclosing functions, and then global, which there's no global x function, and then built-ins. So it threw an error there. Okay, so now let's go ahead and set that back to how it was, where we comment out that inner x and uncomment out that outer x and rerun that. Okay, so when we looked at our global and local variables, I showed you how you could use that global statement in order to explicitly tell Python that you wanted to work with the global x variable. So you may be wondering if there's a way that you can do this with the enclosing scope variables as well. And there is a way to do that. So let's say within our inner function here that we wanted to actually change the x variable of our outer function. Now, we shouldn't use global because global will affect the global scope. In this case, we'd use the non-local statement. So up at the top here, atop of this inner function, I'm going to say non-local x and save that. Now this will allow us to work with the local variables of enclosing functions. So in this case, it means that we're now affecting this x variable of the outer function. So now if I uncomment out that inner x and I rerun this, and now you can see that it prints out inner x twice. And that's because when we set our x here to inner x within our inner function, we were actually affecting that local x of our enclosing function. So it prints out inner x within this inner function, and also when we print it out here, it got overwritten here, so now it prints out inner x twice. Now I can actually see the non-local statement being used more often than the global statement because non-local can be useful in order to change the state of closures and decorators and things like that. Now I'm not going to go into closures and decorators in this video, but if you're interested, then I do have a video on both of those topics. And if you watch those, then you could probably think of some use cases where using this non-local statement could be useful. Okay, so now just to wrap all of this up, let's remove this non-local statement here, and let's uncomment out our global x variable here at the top, and here at the bottom, I'm going to uncomment out where we print out that global x variable. So now if I was to run this, we're simply setting an x variable in each of these scopes and then printing them out. So now that we've gone over the LEGB rule, then you should know exactly what would happen if I was to come in here and comment out where I set the x here within this inner function. So if I run that, then you can see that when we printed that, it didn't find it in its local scope and instead fell back to that enclosing scope. And if I was to comment out where I set the x here within this outer function and ran that, then you can see that each time we printed all of those X variables, then it doesn't find either of these in their local scopes or their enclosing scopes, and instead falls back to that global scope and that global X string. And if it didn't find anything in that global scope, then it would look in that list of built-ins that we looked at earlier. And if it doesn't find it there, then an error is thrown. And also after this video, you should know how to use the global and non-local statements to change the values within those scopes if need be. So I think that's going to do it for this video. If you have any questions about what we covered, then feel free to ask in the comment section below, and I'll do my best to answer those. If you all enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, then you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.